today's lesson, we'll look at more gas law problems, this time specifically working with Guy-Luszak's law and the combined gas law. Okay, let's begin with the first problem. We have a 100 milliliter sample of gas under a pressure of 1 atmosphere. We heat it from 20 degrees to 60 degrees Celsius, and we want to know the final pressure if the volume remains constant. So we have, first of all, a volume, 100 milliliters, under a pressure of 1 atmosphere. We have a temperature of 20 degrees Celsius, and let's say we want to know what is the final pressure. If we increase the temperature from 20 to 60, so T, the new temperature is going to be 60 degrees Celsius, and volume is 100 milliliters. So at this point you should recognize that if we have a variable that is the same, it's no longer a variable, it's a constant, and we can eliminate it from the problem. So we end up with a relationship between pressure and temperature, initial conditions, final conditions. So our equation would have pressure over temperature equals pressure over temperature, initial, final, because pressure is directly related to temperature. And we have Celsius temperature, so we need to add 273 to be able to get the Kelvin temperature. This is 293 Kelvin. And then 333 Kelvin here. Okay, so our initial pressure, 1 atm, divided by the initial temperature, 293 Kelvin, equals the new pressure, P2, over a new temperature, 333 Kelvin. So P2 is going to be equal to 1 atm multiplied by 333 Kelvin over 293 Kelvin. All we did was cross multiply to leave P2 isolated on this side. Okay, so it really just works out to be the temperature ratio, 333 divided by 293. Kelvins cancel, and the new pressure is 1.14 atmospheres. So we increase our temperature, therefore we increase our pressure. Direct proportion. Next problem, we've got a 5-liter container. Volume equals 5 liters. It is constant volume, so it's not going to change in volume, so that means immediately that we can eliminate volume. It's filled with nitrogen to a pressure, P, 1,000 kilopascals, when at a temperature of 25 degrees Celsius. And go ahead and convert that to Kelvin. It's 298 Kelvin. We have a new pressure that the tank rises to of 1,200 kilopascals, so the pressure goes up by 200 kilopascals. We want to know what is the new temperature. And we can say that if the pressure goes up, the temperature should go up, so we should end up above 298 Kelvin. Initial conditions, we know both. Final conditions, we know only one of them, the pressure. P over T equals P2 over T2. And we're going to solve for T2. So we've got the initial pressure, 1,000 kilopascals over 298 Kelvin equals P2, 1200 kilopascals divided by T2. Alright, so doing the math, that's going to give us T2 times 1000 kilopascals equals 1200 kilopascals times 298 Kelvin, cross multiplying there, divide out by 1000 kilopascals, and T2 equals 357.6 Kelvin. Okay. That would be an appropriate temperature. If it was asked for in Celsius, we would subtract 273, and that would give 84.6 degrees Celsius. So either of these answers would be appropriate. Okay, in our last problem, we have the combined gas law. The combined gas law combines Boyle's, Charles, and Gay-Lussac's all together. So we would have pressure times volume over temperature equals pressure times volume over temperature. Okay, so those are all the initial and final conditions. So just really, if you look at the equation, you can see that all three are thrown together into the same equation. So hence the name combined. Let's sort out the variables. We've got a volume of 2.53 cubic meters at a temperature of -15 and a pressure of 191 torr. What volume will it occupy at a temperature of 25 degrees Celsius and a pressure of 1,142 torr? So we've got both temperature and pressure increasing. We adjust our temperatures to Kelvin. It's going to give us 258 Kelvin and 298 Kelvin. So we have our equation P1V1 over T1 equals P2V2 over T2. P1 is 191 torr times V1, 2.53 cubic meters, divided by T1, 258 Kelvin. That equals P2, 1,142 torr, times V2, that's what we're solving for, divided by T2, which is 298 Kelvin. So this becomes 298 Kelvin times 191 torr times 2.53 cubic meters equals 1142 torr times 258 Kelvin times V2, cross multiply. We're going to divide out this side, 1142 torr, 258 Kelvin. That isolates V2 on this side, and then we just have to plug this in our calculators. That leaves us with V2 equals 0. And we need to go to 2 sig figs, it appears, due to the temperatures. 0.49 Kelvin cancels, torr cancels, and you're left with cubic meters. And that would be the final answer. And that's an example of both the Guy-Luszak's law and the combined gas law. You should see more problems in class.